All right, today we're going to look at one more thing here with probability and possibilities, and that is if you get some kind of diagram. So we're going to be looking at Venn diagrams and also averages. And what we're going to be looking at is that you can find the probability from a Venn diagram and that you can calculate weighted averages. Uh, on this first example, you can see there's a Venn diagram. That's where you have overlapping circles here that include information. Anything in the middle here would be people that are in both groups. So this one says, in a survey, 100 adults are asked whether they like coffee, which is this C oval here, and whether they like tea. Okay, that's indicated on here with the T. That would be this other one. All right, the Venn diagram shows the results. So what we should be able to do from here is answer some questions about probability and how many people like each. So part A says a person is chosen at random. Find the probability that the person does not like coffee. Okay, so if we're going to find the probability that they do not like coffee, we need to look at that group of people over the total. Well, we know the total. They told us there's 100 people here. Now, if that wasn't given to us, we could also calculate that by adding up all the different groups here. So if we added up the 13 people who only like coffee, the 46 who like both coffee and tea, the 25 people who only like tea, and then the 16 would be people who don't like either. That should add up to 100. But we know it's 100 they told us. Okay, now we got to find the people who do not like coffee. So what that would be here would be the people who only like tea and the people who don't like anything, which would be these two. So if we add up 25 and 16, that would be 41 people out of this do not like coffee. So the answer would be 41 out of 100, and I don't think that simplifies at all. So that would be our answer. If they wanted it as a percentage, then they would be 41%. Okay, let's look at B. On B, they want to know a person who likes tea is chosen at random. Find the probability that this person also likes coffee. Okay, so now our total is not going to be out of 100 because they're only looking at the people who like tea. So the total people here who like tea would be adding 46 plus 25, we get 71. There's 71 people here who like tea. Out of those people, how many like coffee? That would be this overlapped section here. These are the people who like both. So we would have 46 out of 71 would be the answer. Okay, part C. Two people are chosen at random. Find the probability they both like coffee. All right, so on one like this, we've done these ones now that where you look at more than one thing. We want to figure out if two are chosen, well, what's that probability? So think about what's the chance of the first one? What's the chance the first person likes coffee? Well, we know from our diagram up here that 13 people only like coffee, 46 like both. That's a total of 59 people liking coffee. So our chances that the first person picked likes coffee would be 59 out of 100 people. Assuming that that first person picked likes coffee, what's the chance the next one? Well, how many people would be left to choose from? 99 people. And there would be 58 left that like coffee. So if you multiply these probabilities together, we should get our answer here. So remember, when you're multiplying fractions, multiply the denominators, multiply the numerators, and see what you get. On this one, if you multiply that out, you get 3,422 people out of 9900. And if you simplify that, that does simplify as a fraction. Remember, you can do that on your calculator by typing in those two numbers. If you just hit divide, that'll tell you the percentage. It looks like it's about 34.6%, but if you hit your math fraction button, it'll tell you as a simplified fraction. So we'd have 17.11 out of 4950, or that's about 34.6%. Okay, so that's Venn diagrams. You should be able to look at those and answer some questions when you try to practice. This next example gives us a frequency chart. We should also be able to answer questions using that. And we're going to be looking at, here it looks like average. So it says Isabella went up and down the street to find out how many parking spaces each house has. Below are her results. What is the average number of parking spaces? Okay, so when we talk average, you are looking at adding up all the number and then divide it by how many there are. That's how you find average. Well, this frequency chart shows the number of times each parking spot occurs. So there's 15 times where there's only one parking space. There's 27 times where there's 2 parking spaces, and so on. So what we can find out here is how many total parking spaces there are going to be. If we add up all these frequencies, that's how many the total number of times that we would get a parking spot. So we want to add these up. So let's add together 15 plus 27 plus 8 plus 5. So when we do that, it looks like the total here is 55. So when we're finding our average here, on the bottom, we're going to have 55 because that's how many times total that we looked. But we need to know how many total parking spots there are for the top. So how many total parking spots were there? Now, we don't want to just add 1 plus 2 plus 3 plus 4 and get 10. That's not how many total parking spaces. That's how many spaces there were this many times. So if there's one parking spot 15 times, that means you had, if you multiply these together, 15 parking spaces. Okay, if 27 times we had 2 parking spaces, if you multiply that together, that means there were 54 total parking spaces. And if we keep doing that and multiply all these together, that means here, this is the total parking spaces that we had. So what we want to do is also now total up this number. What do all these add up to? So if we add all these up, we should get 113. So there's 113 parking spaces. Okay, it occurred 55 times. So what's the average number of parking spaces? Well, now we would divide these out and we would get the average. So if we take 113 divided by 55, it means on average there was 2.05 parking spaces each time. Okay, so average you want to look at adding them all up over how many times it happened. All right, now these next examples are going to be average, but these are what are called weighted averages. And weighted averages are found a little bit different because the weight means there's a percentage that's attached to how much each category has. Oftentimes your grades are calculated like this. In fact, your grade for this class is calculated like that. So this one said the final grade for a class is calculated by taking 75% of the average test score and adding 25% of the score on the final exam. And then it goes on to say if all scores are out of 100 and a student has 76 test average, what score does a student need on the final to have a grade that's at least 80? Well, let's look at this type of problem. If we know we have percentages, okay, anytime you're doing a problem with percentages, you need to change that to a decimal. So 75%, okay, 75% of our testing, well, let's use T for testing, plus 25% of our final, Okay, we want to change those to decimals. So it'd be 0.75 of our testing plus 0.25 of our final. That's how we calculate our grade. Now, this person wants to know, they want to get a grade of at least 80. Okay, we've talked about at least. That means we want it greater than or equal to 80. This person looks like they probably want something higher than a B or higher here. So what we need to do now is plug in what our test score is and what our final score is, or solve for one of them. Now they tell us here that the student has a 76 test average. That means we know what they got on their tests. What we want to find out is what do they need on that final. So let's plug in what we know and solve for what we need. So if we take 75% of 76, 25% is going to be from the final. We want that greater than or equal to 80. Let's solve this out. So on your calculator, you want to find out what is 75% of 76. So 0.75 times 76. That means 57 is going to come from their tests. If we now subtract that, that means we need greater than or equal to 23 points to come from the final. If you divide that by the weight, it should tell us what they need on the final. So it looks like on the final here, this person needs to get greater than or equal to, if we divide this out, looks like a 92. They need a 92 or higher on their final to end up with a B. 92% or greater. Okay, so on this next one, we're going to kind of be doing the same thing here. Why don't you pause this video, see if you can try this one out and figure out what this person needs. All right, let's see how you did. On this one, we got 70%. So let's change that to a decimal. That would be 0.7. And that is for average test score. Okay, so if you want to come up with a variable for that, we'll call it T, plus 15% is homework. That'd be 0.15 for homework, plus another 15 for final here. And this person wants to have at least a 90, so greater than or equal to 90. Okay, so now we got to put in all the things that they got here. So for test, this person got an 87. For homework, they got 96. We do want to know what do they get on that final. So now we got to plug in the information and see what we get here. So we got 0.7 of 87 plus 0.15 of 96 plus 0.15 F. Is that greater than or equal to 90? If you solve this one out, now we should get to where we need. This one is going to come out to be 6.9. If we add these up, we want to subtract here, and we're going to get 14.7. If you divide by 0.15, you should find out that they're going to have to get a 98 or higher, looks like, on the final for this one. So that's what if you got that, you're doing a great job. Okay, there's a part B to this one. On part B, they want to know, what does he need on the final exam to have a final grade of at least a 93%. Okay, so Now we're looking instead of 90, so it's basically the same problem, but how do they get that to be greater than or equal to 93%? So we want to write it down basically the same thing here. 0.7, again, times 87 plus 0.15, we got a 96, plus 15% of the final, this time greater than or equal to 93. If we multiply these together, again, we should get the same thing that we got last time, which equals 75.3. Okay, subtracting here, that's going to give us 17.3. And then if we divide by 0.15, okay, we get 118. So they got to get 118 on their final. Is that possible here? No, they're not going to be able to get this. You can't get over 100% here. So if this person wants that A+, but unfortunately for them, with what they got on their homework and tests, it's not going to be possible here because that's over 100%. So it's not possible on this one. They're not going to be able to get that grade here. All right, one last one. On example 5, it says John's math grade is determined by taking the average of 5 tests. If John got the following test scores, 87, 85, 93, 88 on his first 4 tests, what does he need to get on his 5th test to get a B, which is an 80%? Okay, now this is not a weighted problem like we were doing here. This is back to regular old average. And remember, like we did on that frequency problem, if you're finding average, you want to get your total over how many times it happened. So it looks like here, John is taking 5 tests. So we want to divide by 5 here. On top, we want the total test score. Okay, but we don't know what that is right now. We only know 4 of them. We want to add together 87, 85, 93, 88. But John hasn't taken his last test yet. So there's still one more test that we're unsure of that is also going to get calculated into this average. Because we need 1, 2, 3, 4, 5 tests if we're dividing by 5 here to find the average. But we do know what he wants that average to come out to be, and that's an 80. So we need to solve this now for x. Okay, now if we're solving for x, we want to try to simplify this. One thing we could easily simplify is adding these other 4 test scores up. So let's do that. Let's add together all his other tests. So 87 plus 85 plus 93 plus 88. All his other 4 tests added up to 353 points. Okay, so where do we go from here? Well, we need to get x by itself. And right now we can't minus 353 yet because it's being divided by this 5. Well, we want to get rid of that 5. What's the opposite of dividing? Multiply. Let's times both sides by 5 here. Then these 5's cancel out. So now this side we're left with the 353 points he's got so far plus whatever he gets on this last test would equal 80 times 5 is 400 points. He needs 400 points total to get to his B here, his 80%. So now the last thing we would need to do, subtract the points he has already to figure out what does he need on that last test. So if we subtract that, it looks like he's going to need 47 on his last test in order to get his average to be 80, which shouldn't be too hard looking at his other tests. 47 is not going to be, hopefully, too hard for this guy. All right, you're going to try some of those out now on your own.